In today's room, we have the OSI model. This can be under pre-security and TRYHACKME. Should be a free room. So the OSI model, or open system interconnection model, is an essential model used in networking. This critical mode provides a framework dictating how all network devices will send and receive interpreted data. One main benefit of the OSI model is that devices have different functions and designs on network while communicating with other devices. Data sent across network that follows the uniformity of the OSI model can be understood by other devices. The OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and range from 7 to layer 1. At every individual layer, the data travels through a specific process, takes a place, and pieces of information that are added to this data, which that we'll come to discuss in the upcoming tasks within the room. However, for now, we only need to understand that this process called encapsulation is what the OSI model looks like in the diagram below. So you can see all the 7 layers we have, starting at the physical, then data link, network, transport, session, presentation, then ends at the application. Maybe you see it. What does OSI model stand for? Open system interconnection. How many layers does it have? 7, of course. What is the key term for when pieces of information get added to data? Encapsulation. Encapsulation, you'll see that word a lot in cyber. So start off with the physical layer. It's layer 1, the easiest layers to grasp. Put simply, this layer references the physical components of hardware using networking and is the lowest layer you will find. Devices use electrical signals to transfer data between each other in binary numbering systems, 1 and 0. For example, the Ethernet cable device such below. Yeah, it's really just hardware. The physical layer, no power coming to it. Maybe a cable's busted. Physical, name, number system, binary, of course. What is the name of the cables that are used to connect devices? Ethernet cables. Data link. The data link layer focuses on physical addressing of transmissions. It receives packets from the network layer, including IP addresses from the remote computer, and adds in the physical MAC. MAC is media access control, addressing the receiving endpoint inside every network-enabled computer is a network interface card, NIC, which comes to a unique MAC address to identify it. MAC addresses are set by manufacturers and literally burned into the card. They can be changed, although they can be spoofed. When information is sent across the network, it's actually the physical address that is used to identify where exactly to send information. Additionally, it's also the job of the data link layer to present the data suitable transmission. So the name of this layer, data link, of course, was the name of the piece of hardware that all network devices come with, a network interface card, which is the NIC. Layer 3 is going to be the network layer. The third layer, network 3 is going to be the network layer. The third layer of the OSI model is where magic of routing and reassembly of data takes place from these small chunks to the larger chunks. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent. While some protocols at this layer determine exactly what the optimal path the data should take to reach a device, we should only know about their existence in the stage of the networking module. Briefly, these protocols include OSPF, Open Shortest Path First, and RIP, Routing Information Protocol. The factors that decide what route is taken is decided by the following: what path is the shortest, what path is most reliable, which path has the fastest physical connection. At this layer, everything is dealt with via IP addresses. Devices such as router capable of delivering packets using IP are known as layer 3 devices because they are capable of working third layer. So we see a picture right here, just kind of, seeing the routes that it could take. What is the name layer network? Optimal route. Will packets take the most optimal? Of course. What is acronym? Open Shortest Path First, RIP, Routing Information Protocol, of course. What type of address are dealt with at this layer? IP addresses. Layer 4, it's going to be transport. There's actually 2 types of transport, TCP and UDP. TCP is Transmission Control Protocol, potentially hinted by the name. This protocol designed with reliability and guarantee in mind, reserve a constant connection between the 2 devices for a amount of time to Not only this, but the TCP incorporates error checking to design. Error checking now TCP can guarantee data sent from small chunks in the session layer has been received and assembled in the same order. So advantages of TCP: guarantees accuracy of data, compatible between two devices, prevents it from being flooded, performs a lot more processing for reliability. Um, the disadvantages, because it has to be accurate, so has so I'll just read it. It requires a reliable connection between the two devices. If one small chunk of data is not received, and the entire chunk of data cannot be used, a slow connection can be bottleneck another device, which will reserve receiving computer the whole time. Slower than UDP. Yeah, UDP is going to be more like watching a show or something. TCP is going to be like more like information, getting it through. TCP is used for situations such as file sharing, internet browsing, sending email. This usage because service requires data to be accurate, complete, no good of having half a file. And the diagram, you can see the picture broken down from web server reconstructs the picture in the cat. Packet 1, packet 2, packet 3. So if any of these packets go missing, the final can be completed. UDP, this protocol not nearly as advanced as its brother TCP. Doesn't boast many features offered by TCP, such as an error check and reliability. In fact, any data that gets sent to the computer, whether it gets there or not, there's no synchrony between the two devices. You guarantee just hope for the best and fingers crossed. While the sound disadvantage, it just have its merits. Will layout UDP much faster, of course. Size packet. UDP does not reserve a continuous connection as TCP does. A disadvantage: UDP doesn't care if data is received. It's quite flexible software. This means that unstable connections result in a terrible experience for the user. Using same example as before, it will go through. Not all packets win, but it's still gonna come. So it's like a fucking head on some shit. UDP is useful in situations where there's small piece of data being sent. For example, protocols discovering devices, ARP, DHCP that we discussed in room 2. I'll make a video on that room. Larger files such as video streaming where it's okay. Pixels. What's the name? Layer transport. TCP stands for transmission control. User datagram protocol for UDP. Accuracy of data, TCP, of course. What protocol doesn't care? UDP. What applications? You want to email, the full email to come through, so TCP. Download files, you want the full files, TCP. Stream videos, like I said earlier, UDP. Sessions. Once data has been correctly translated or formatted from the presentation, the session layer, this will begin to create and maintain the connection to the other computer for which data is destined. When a connection is established, the session is created whilst the connection is active, so is the session. The session layer is also responsible for closing the connection if it has been used while or if lost. Additionally, a session can contain checkpoints where if the data is lost, only the newest piece of data are required to be sent, saving bandwidth. What is worthy of noting, the session unique mean the data cannot travel over different sessions, but in fact only across each session instead. Name layer session, technical term when connection established session. Alright, presentation. Layer 6 OSI model is layer in which standardization starts to take place. Because the software developers can develop any software such as email client differently, the data still needs to be handled the same way no matter how the software works. This layer acts as a translator for data, and from the application layer 7, the receiving computer will also understand data sent to a computer and formatted destined for another format. For example, when you send an email, the other users may have another email client to you, but the content email will still need to display the same. Security features such as data encryption like HTTPS when visiting a secure site occur at this layer. And layer 7 be application, so you need that HTTPS to protect the application, of course. Layer. Main purpose of this layer acts as a translator, maybe a bodyguard as well. This application layer of the OSI model is the layer that you'll be most familiar with. The familiar because the application layer is the layer which protocols and rules are in place to determine how the user should interact with data or sent or received. Everyday applications such as email clients, browser file, such as FileZilla provides a friendly graphic user interface. GUI for users to interact with the data sent or received. Other protocols include DNS, domain name system, which is how websites address are translated into IP addresses. Just can see here, just some applications. Name layer application, what the technical term given to the name of the software that users interact with. Graphical GUI. Can you escape the dungeon? Obviously, I've already done it. Oh, what comes first? Is that what it is? I didn't read it. Fuck, I didn't read it. I look, you didn't read it. Can you escape dungeon? Can you beat our staff high score? 19 seconds. Click the restart button right to start. Oh, I'm tripping. Enter. This space. Oh, it's space. Alright, and then what do we have? We have data link, of course. Cool little mini game. TRYHACKME is actually a really good website for learning cybersecurity. Yeah, I'm on a 122-day streak, so yeah, just grinding, and I thought I'd make some videos for y'all. Session's gonna come before, of course. It's definitely not transport. And then we'll end it off with application. Cool little mini game they got. 68 seconds, whatever. So the conclusion, this will be a different room. Definitely make a video on it, but that's all I got for the OSI model room. Hope y'all enjoyed. Hope y'all like these videos, and yeah.